might have heard about Git, maybe even used it. But do you know all the Git commands? Well, if no, you are in the right place because in this video, I'll cover all the Git commands from basic to advanced. I'll break down each command in detail so you'll know exactly what's going on. But before we dive in, let's quickly understand what Git is and how it works. Ready? Let's get started. Git is like a super organized and smart assistant for developers. It keeps track of all the changes we make to our code over time, storing them in a special place called a repository. This way, we can look back at our project's history, see who did that, and fix things easily if we mess up. Without Git, we would have to make tons of copies of our whole project, which is slow and messy, especially if lots of people are working on it. With Git, we can work together smoothly and keep our project's history in check. There are two main types of these systems, centralized and distributed. In the centralized one, everyone connects to a central server for the latest code. But if that server goes down, it's a big problem. Whereas in the distributed one, like Git, everyone has their own copy of the project. So if the central server has a bad day, we can still keep working and share our progress directly with others. Git fundamentally operates with three main components: the working directory, the staging area, and the repository. The working directory is where you make changes. When you commit, Git takes a snapshot of this directory and stores it in the repository. These snapshots are identified by unique hash codes, calculated based on the contents of the commit, and ensures the integrity. Each commit in Git is like a link in a chain, connected to the previous commit by its hash. Branches in Git are simply pointers to a specific commit. When you create a new branch, you are essentially creating a new pointer. The head in Git is another pointer, indicating which branch you are currently on and points to the latest commit in that branch. This was just an overview of how Git works under the hood. Next, we'll explore all the basic to advanced Git commands with details. Alright, let's start from scratch. I've created this GitHub repo to which we'll be pushing our local changes. Now, if we want Git to start tracking our local changes, we have to initialize our repository first. To do that, we can use git init. What it'll do is, it'll create a hidden folder called Git, which has a bunch of other files and folders inside. These files and folders contain all the content needed for Git to reference that particular directory. Now, by default, this directory is hidden and we don't have to worry about it. Alright, let's add some files now. I'll create a new file called index.js. And for now, I'll add a sample console log. Now in Git, we have three states: modified, staged, and committed. Whenever we add, remove, or change something in a file, that file is in modified state. When we inform Git of the change and tell Git to take note of that change, the file is in staged state, also commonly known as staging area. The committed state is when Git has saved your modified changes. In this case, index.js is in modified state. To check a state of a file, we can use git status command. Here we can notice index.js is currently in untracked files. To add this file to the staging area, we can use git add command and add the path of the file. Now if we can check the status again, we can see that index is now added in the staging area. Now comes the third stage, which is committed state. We can simply add a commit and add our message. And that's it. We are ready to push our first change. Before we push our changes, we have to let the Git know to which remote repository we want to push our changes to. Now to add a remote repository, we can use this command git remote add origin and the URL of our remote repository. Now git remote add means we want to add the reference to our remote repository, and origin is that reference. Now origin is a commonly used name, but we can choose a different name if we prefer. And we can just press enter. Now if we have already added, we can see that remote origin is already exists. Now we are good to go. I can just type git push origin, and my branch name, which is master. And with this, all of our contents or all of our changes from local will be pushed to our remote repository. We have successfully pushed our first commit to master, but it's a good practice to never commit to master directly. Instead, we should create a separate feature branch, make our changes there, and then create a pull request to merge our changes to our master branch. Let's see this in action. Now let's first check which branch we are currently on. To do that, we can type git branch, and we can see we are currently on master branch. Now to check out a new feature branch, we can type git checkout -b. -b is basically to create and check out to the feature branch, and then our feature branch name. Let's make it feature 1. Now let's create a new file and name it readme, and then a sample text. Now let's try to raise our pull request and merge to master. So first I'll add my file to staging area, then I'll add a commit. And then I'll push the changes to feature 1 branch. We have successfully pushed our changes. Now let's go back to our GitHub repository. Let's click on compare and pull request. Here we can see we want to merge to our master branch, and then we can raise a pull request. And then basically what we do is we merge our pull request. So we do confirm merge, and all the changes will be merged to our master branch. We have successfully merged feature 1 changes to master. But if I check out to master, we can see that readme file is not there because I haven't updated my master branch with the remote repository. To do that, I can just type git pull origin master, and it will basically update my local branch with the remote repository. We can use git log command to check all commits in a branch with extra info like the commit hash, whether it is merged from another branch, the author name, on which date it was merged, and the commit message. Stashing is a way to temporarily store changes without creating a commit. Git stash command is used to save changes in our working directory that are not yet ready to be committed. Let's create a new file and name it file1.txt. Let's add a sample text. Now let's first add this file to our staging area. And then to add this file to stash, we can just say git stash. Or if we want to save this stash with a descriptive name, we can say git stash save and the name. Let's say file1. Now let's add another file and name it file2.txt. Let's add this file to our staging area as well. And then to add it to stash, we can use the same command and use the descriptive name to be file2. Now let's see our stash list. To do that, we can just type git stash list. And then we can see we have 2 stashes in our list, stash 1 and stash 2. Now let's say we want to apply the changes of stash 1 to our working directory. To do that, we can say git stash apply or git stash pop. Now the difference is both of them will apply the stash changes to our working directory. The difference will be a pop will remove the stash from the list, whereas apply won't. Let's use apply. Now git stash apply will apply the latest stash changes to our working directory, which is file2. But let's say if we want file1 to be applied on working directory, we can use the index. So git stash apply and 1. So it will apply file1 changes to our working directory. Let's say we want to drop a stash. So for that, we can say git stash drop and the index, let's say 0. So it will drop 0th index stash from the list. So we can just confirm. Now we have just one stash in the list. Let's say we want to update our file name. The easier way would be we can just go to our directory, right click, and we can rename it. But if we want to do it via Git, we have a command. We can just type git mv, type our file name, and then the new file name, let's say test.js, and it will replace the file name. Now with git mv, we cannot just update our file names, but we can change the path of our files as well. Let's say I want to move my test.js file inside my src folder. So I can do that with git mv. I can type my file name, test.js, and then where I want to move it. Let's say in src. So it will move test.js in src. If we want to remove files from both our working directory and staging area, we can use git rm command. Now here I have created a test folder and a bunch of test files. Now if I quickly type git status, we can see all these files are added to the staging area as well. Now let's say I want to remove test1.js. So I can just quickly type git rm test/test1.js. If I enter this command, I can get this warning that this file has been added to the staging area. Now I can do two things here. Either I can add -" cached flag. What it will do is it will remove this file from staging area and will add this file to the modified state. Or I can use -f flag to force removal. So if I retype that command and add -f, this will remove this file, both from the working directory as well as staging area. Now let's say we want to remove multiple files. What we can do is, let's say I'll remove test2.js, and then we can add a space, and then we can just type test3.js, and this will remove multiple files. Now if we want to remove a complete directory, let's say, then we can use git rm, we can use -r flag, and then our directory name, which is test. Now again we'll get the same warning. We'll use -f flag, and this will remove the complete directory. If we want to show changes between two states of a Git repository, or compare changes between working directory and the staging area, or to compare changes between two commits, we can use git diff command. Now here I have added a folder, infra, and 3 environment files. Now I can quickly show that I've added these files in the staging area. Now if I want to compare changes between staging area and the last commit, I can just type git diff and add the staged flag, and it will show the changes between staging area and last commit. Now let's quickly break down what this means. A/infra dev.env means this is the path of the file in the working directory before staging, and this is path of the file in the staging area. Now new file mode means it's a new file with 5 permissions. This shows the old and new object ID for the file content. It represents the file state before and after staging. This indicates that the file did not exist in the previous commit. It's a new file. This is path to the file in the staging area after staging. This indicates the line range where the file occurred. In this case, it's showing a new line was added at line 1. This is the actual content change, indicating that the line node env was added to the file. This is a common message indicating that there is a no new line at the end of the file. Now similarly, we have for production and staging env as well. Now let's say we want to compare changes between two commits. Let's type git log to see all the commits in our repository. Now let's say I want to compare changes between first commit, which is my latest one, and this one. So I can just type git commit and then my commit hash, this space, and then the other commit with which I want to compare. Let's say this one. Okay, I made a typo. This should be git diff and then my commit hash. And then it will show me the differences between these two commits. If we want to search through our Git repository for a specific pattern in the contents of files, we can use git grep command. So to search a pattern, we can just write git grep and a search pattern. Let's say we want to search node env, and it will show all the files that has node env. Now, if you want to search a specific pattern in a file, that file should be at least in staging area, or it should be pushed to the repository. Now, to show this, I have added two files, user.js and user.css. Now, to quickly show the status, we can see that these files are still in untracked. So let me quickly show what this file is doing. So in user.js, we are just generating random username. So if I try to find random, I won't get any result because this file is not yet in staging area and Git cannot track this. So let me quickly add this to the staging area. Let's quickly confirm. Let's These two files are added in staging area. Now if I again type that command, I'll get all the occurrences of random in these two files. Now, if we want to find our pattern in a specific directory only, we can just type git grep our search pattern, let's say test, and then we can we can define our directory, let's say src, and then it will find that pattern in that directory itself. Let's say we want to search our pattern in a specified file type. For that, we can just type git grep our search term, let's say we want to search random, and then hyphen hyphen, and then in which file type we want to search. Let's say we want to only search in JS files. So it will search in only JS files, not in CSS. If we want to remove untracked files and directories from our working directory, we can use git clean command. Untracked files are files that are not under version control and have not been staged for a commit. Now here, if I quickly type git status, we can see this user directory that has user.js and user.css and this logger.js file. These two are currently untracked and have not been added to staged yet. Now, now if I type git clean, I'll get this warning that require force is by default active. So I can use either of these three flags. Now -i means that we can open git clean in interactive mode, which we don't want for now. With -n, we can see which files will be deleted when we run git clean. Now here we can see that logger.js will be cleaned or deleted. Now if we want to see the directories as well, we can type git clean -d and then -n, and then it will show logger.js and user directory will be deleted. Now to delete, we can just type git clean and then specify the -f flag to forcefully delete all the files. Now it will delete logger.js. And if we want to remove the directory as well, we can type git clean -d and then -f. And it will remove the user directory as well. So if we quickly type git status, we can see there are no files that are currently in untracked. Git fetch command is used to retrieve changes from a remote repository, but it does not automatically merge those changes in our working branch. It's a way to update our local repository with changes made in the remote repository without automatically merging them in our working branch. To use fetch, we can just type git fetch and then origin. And it'll fetch all the changes from our remote repository. Now git fetch means it'll retrieve new branches, updates the remote tracking branches, and fetches any new objects from the remote repository. And origin is the default name of the remote repository that we set earlier. Now to confirm if we have successfully fetched the changes from our remote repository, we can either use git log or git diff. So in this case, if I type git log, I can see all the commit changes from the remote repository, However, our local working branch will remain unchanged until we explicitly decide to integrate the changes. Git merge command is used to combine changes from different branches. It merges changes from one branch into another, typically bringing the changes from a source branch into the target branch. Now here I have created a feature branch called feature2. If I quickly show the contents inside it, it has two commits, logger and user, and similarly we have two files. Now, now if I quickly go back to VS Code and quickly type git branch, we can see I've created a new feature branch called feature3 and I have checked out to it. Now if I want all of my contents from feature2 branch in feature3, I can just simply type git merge and my source branch, which is feature2, and it will copy all the contents from feature2 to my feature3 branch. But if we want to merge a certain commit from a feature branch, we have a way for that one as well. Let's say in my feature branch, I just want logger. So I can just copy the commit hash, go back to my VS Code, and let's check out to a new feature branch. Let's check out to master first. And then from master, let's check out a new feature branch. And let's say I want only logger changes from feature 2 to my feature 4 branch. So what I can do is I can just type git merge and paste my commit hash that I want. And if I press enter, we can see that logger file is added. Conflicts can occur during a merge, especially if changes in the source and target branches affect the same lines of code. Git will notify you if there are conflicts, and you'll need to resolve them before completing the merge. Now here, let's check out a new feature branch, feature 5. And in here, in the source directory, let's create a new file, logger.js. And for now, let's add a console log, new logger. Now in feature2 branch also, we have this logger file where we have console log added as just logger. So when we'll merge feature2 branch in a feature 5, we'll get a conflict. Let's see that. Git merge and then feature2. Now before merging feature2, we have to add our changes to the staging area. Let's add that and commit as well. Now if I try to merge feature2 in a feature 5 branch, we'll get a conflict. So console log logger is coming from feature2 branch, which is the incoming change, and our current change is new logger. We have to select either of these two. Either we have to accept the current change, incoming change, or we can accept both changes. Let's say we'll accept the incoming change. Now we have to manually add these files to the staging area and then commit them. And we are good to go. Cherry pick is used to apply a specific commit from one branch to another. It allows us to choose a specific commit and bring its changes into our current branch. Now here I've created a new feature branch, feature 6. Now let's go back to the feature 2 branch. Here, let's say we want to add the logger changes to our current branch. So I'll just copy the hash and go back to our feature branch. So what I'll do is I'll just type git cherry pick and just paste our commit hash. And it'll copy the logger changes in our feature branch. But wait, we did that using merge as well. So what's the difference between merge and cherry pick? When we use cherry pick, it creates a new commit with a new hash, whereas merge retains the original commit hash. In cherry pick, commits are copied and their history is not preserved, whereas merged commit retains their history, showing the branch from which they originated. Git switch command is used to switch between branches. It's a more user-friendly and safer alternative to Git checkout. So to create a new branch with git switch, we can just type git switch -c to create a new branch and then our branch name. Let's say feature 8. And it will create and check out to our new branch. To check out an existing branch, we can just type git switch and the branch name, let's say master, and it will switch to master. If we want to switch to a previously checked out branch, we can just type git switch and hyphen, and it will switch back to feature 8. Git reflog is a command that displays a log of reference changes in our Git repository, including information about when the changes occurred and what operations were performed. It's particularly useful for recovering lost commits or branches. So if we just type git reflog, it will show the reflogs for all the branches in our repository. So we just press enter and go at the end. We can see we started with the initial commit. Then we created a feature one branch from master and checked out to it and added few commits. And then we move back to master and then check out a new branch. And similarly, we can have all the logs. Now, if we want to see logs for a particular branch, we can just type git reflog and the branch name. Let's say we want to see for master, and we can get the reflogs for only that branch. Git reset is a versatile tool that allows us to undo changes, unstage files, and move the head pointer to a specific commit. Now here I have created a new feature branch. I've added a new file, logger.js, and I've added to the staging and then commit this. Now we can see the logs that head is pointing to the latest commit. Now if we want to remove this commit and keep the changes in the staging area, we can just type git reset, add the soft flag, and then mention the head pointer, which is currently pointing to the last commit. If we press enter, and then if we just quickly type git status, we can see that logger is now added to the staging area. Now let's quickly make another commit and add this file to the commit list. Now let's say we want to remove the commit, but we don't want the file in the staging area. We want this to be in the untracked files or in the modified state. For that, what we can do is we can do git reset, and then this time we'll use mixed flag. And then again the head pointer. So this time, again if I type git status, we can see now logger.js is no longer in the staging area. Instead, it's in untracked files. Now again, let's make another commit and add this file. Now let's say this time we want to delete our last push commit, but we don't want the changes in our local repo as well. So for that, what we can do is we can say git reset, and this time we can use hard flag. And then we can mention the head pointer. So it will remove the last commit as well as it will remove the file as well. Now let's say we want to delete our last two commits. So how can we do that? One way is we do a hard reset 2 times. But if in case we have to delete, let's say 5 commits, then we have to repeat this process 5 times. There is an easier way. Let's say I want to move my head pointer to added readme. So what it will do is it will move the head pointer to this commit and will remove these 2 commits. So to do that, what we can do is we can just type git reset. We can mention the hard flag, and then we have to mention our commit hash, which is this one. So what it will do is it will move this head pointer to this commit and will discard these 2 commits. So if we just quickly confirm, our head is pointing to edit readme and the previous 2 commits has been discarded. Git revert is used to create a new commit that undoes the changes made in a previous commit. Unlike git reset, which alters commit history, git revert creates a new commit to reverse the effects of a particular commit. This is especially useful when you want to keep a clean commit history and maintain a record of changes. Now here I have created a new feature branch. Let's create a new file, logger.js, and add it to our staging area, and then made a commit. Now if we quickly show our logs, we can see that we have added a new commit called edit logger. Now if we want to remove our latest commit using revert, we can just type git revert, and then we can specify the head pointer. So what it will do is it will not remove the latest commit, but instead it will create a new commit and add the revert. So if I just press enter, it will add this interactive mode, and and my commit message will be revert edit logger. So I can just type colon WQ, which stands for write and quit, and then I press enter. Let me clear the screen, and then let me just show the git log. So instead of deleting this log, it created a new commit. Let's say I want to revert a particular commit. So what we can do is we can just type git revert, and then we can copy the commit hash. Let's say I want to remove the edit infra part. What it will do is it will remove the infra folder. So I can just copy the commit hash. So now if we don't want that interactive window to be open, we can add a new flag called no edit. And if I just press enter, what it will do is it will remove the infra folder. So if I quickly show git log, instead of removing that, it added a new commit. Git rebase is a powerful Git command used to modify the commit history. It allows us to integrate changes from one branch into another and rewrite the commit history to create a linear sequence of commits. Now here we previously created feature 2 branch. Let's quickly see that. We added 2 commits in that. Let's try to create a new feature branch, and let's try to rebase that feature branch with feature 2. Let's quickly first create a new feature branch. Let's say feature 3. And then let's add a new file, sender.js. Now let's quickly add it to the staging area and add a commit. Now if we quickly see the git log, notice the commit hash for the latest commit we just added. It starts with 46A. When we rebase our feature 3 branch with feature 2, Git will create a new commit hash for our latest commit. Let's see that. So in order to rebase feature 2 branch with feature 3, we can just type git rebase and our branch name, which is feature 2. So we can see that both of the changes, user.js and logger.js, are rebased to feature 3. Now let's quickly see the commit history. We can notice that Git has updated our commit hash. So what happens is Git is trying to create a linear sequence of commits. Now we know we can do the same thing with merge as well. But how merge is different with rebase? Merge creates a merge commit, resulting in a more branch history. And instead of creating a new commit, it retains the original commit hashes. Let's see that. Let's check out to master first and check out to a new branch, feature 4. Let me clear the screen quickly. And then let's add the same file, sender.js, and add this file to our staging area and then made a commit. Then if we quickly see the Git log, we can see we have our latest commit. But if we try to merge our feature 2 branch with our current branch, what will happen is it will create a new merge commit. We can see, doesn't matter how many commits we had in our feature 2 branch, it will create a single merge commit and will mention the top 2 parent commits. Now let's try to understand how rebase and merge works behind the scenes. Now in case of rebase, we had 3 commits in master A, B and C. And then we checked out 2 feature branches, feature 2 and feature 3. In feature 2, we added 2 commits D and E. And in feature 3, we added 1 commit. Now when we did rebase, what Git did is it tried to maintain the linear history. So it added all the commits from feature 2 branches and all the commits from feature 3 branches it added on the top of feature 2 branch with a new commit hash, maintaining the commit history. Now in case of merge, again we had 3 commits in master and we checked out 2 feature branches. Again in feature 2 we had 2 commits and in feature 4 we added 1 commit. Now when we did merge, what Git did is it created a new merge commit and added on the top of feature 4. Now let's quickly understand the difference between rebase and merge and which one should we prefer. So rebase rewrites the commit history and it creates a new linear sequence of commits, whereas merge tries to create a merge commit and tries to preserve the commit history of both branches. Rebase creates new commits with new hashes, whereas merge creates a new merge commit with 2 parent commits. Rebase produces a clean and linear commit history, whereas merge preserves the original commit history of both branches. So if we want a clean and linear commit history, we can prefer rebase. But if we want to preserve our original commit history of both branches, we can use merge. Git is like the rockstar of version control systems. It's free, open source, lightning fast, and can handle big projects with ease. If you're aiming for a job in coding, having Git on your resume is like having a secret weapon. You gotta know it well, how it works, how to use it to be an effective coding superhero. That's it for this crash course. Thanks for joining. If you found this course helpful, don't forget to hit that like button. Subscribe for more awesome content and let me know in the comments what topics you would like me to cover next. I'll see you in the next video.